Let's go into the second tutorial by understanding the concepts of Apache Hadoop, an open-source software for reliable, scalable. Firstly, let us try to understand how the data is stored and processed using traditional approach. In traditional approach, the data from various sources is given to a system. Then the system extracts and transforms the data to a proper format and finally loads the data into a structured format such as database or Excel sheets. Then the user runs the queries and gets the required output. But when the data grows, this becomes a challenging task for traditional systems to manage and process the data. This is the fundamental drawback of traditional approach. Let's discuss in detail with the fuel economy example discussed in previous tutorial. The fuel economy data from multiple manufacturers is given to an ETL system and it takes care of the extracting and transforming the data. Then the users run their queries and scripts in order to generate the required reports. Now, what if the data generated from various sources increases? This makes data processing a tedious task for any traditional systems. Now let us discuss other drawbacks of these systems. There are three major drawbacks of traditional systems. The first major drawback is it is very expensive and it requires a lot of investment for implementing or upgrading the systems. Therefore, it is out of reach of small-scale companies. The second drawback is scalability. As the data grows, expanding the system is a challenging task, and finally it is a time-consuming system. The data processing and storage takes a lot of time. To overcome these drawbacks of traditional systems, Apache Hadoop, an open-source framework, is developed by Doug Cutting and is managed by Apache Software Foundation. Coming to the definition, Apache Hadoop is a framework that allows for the distributed processing of large data sets across clusters of commodity computers using a simple programming model. Hadoop is designed to store and process huge volume of data efficiently. The Hadoop framework comprises of two main components. The first component is HDFS. HDFS stands for Hadoop Distributed File System. It takes care of storing and managing the data within the Hadoop cluster. The second component is MapReduce. Whereas MapReduce takes care of processing and computing the data present in the Hadoop Distributed File System. Now let's understand what makes up a Hadoop cluster. A Hadoop cluster is made up of two types of nodes. The first one is the master node and the second one is slave node. Master node is responsible for running name node and job tracker daemons. A node is a technical term used to describe a machine or a computer within a cluster, and daemon is used to describe a background process that is running on a Linux machine. Slave node is responsible for running data nodes and task tracker daemons. Name node and data node are responsible for storing and managing the data, whereas job tracker and task tracker are responsible for processing and computing the data. Generally, name node and job tracker are configured on one machine and data node and task tracker are configured on multiple machines. Let's discuss the important features of Hadoop. They are flexibility, scalability, robustness and efficiency. As it is a known fact that only 20% of data in organizations is structured, and the rest is all unstructured, it is very crucial to manage unstructured data which goes unattended. Hadoop is flexible enough to manage different types of big data, whether structured or unstructured, encoded or formatted, or any other type of data, and makes it useful for decision-making process. Moreover, Hadoop is simple, relevant and schmaless. Though Hadoop generally supports Java programming, any programming language can be used in Hadoop with the help of the MapReduce technique. Coming to scalability, Hadoop is a scalable platform in the sense that new nodes can be easily added in the system as and when required without altering the data formats, how data is loaded, how programs are written or even without modifying the existing applications. Hadoop is an open-source platform and runs on industry-standard hardware. Moreover, Hadoop is also fault-tolerant. This means, even if a node gets lost or goes out of service, the system automatically reallocates work to another location of the data and continues processing as if nothing had happened. Hadoop has a very robust and a rich ecosystem that is well suited to meet the analytical needs of developers, web startups and other organizations. Hadoop ecosystem consists of various related projects such as MapReduce, Hive, Base, Zuckerberg, Catalog, Apache Pig, which make Hadoop very competent to deliver a broad spectrum of services. Hadoop has revolutionized the processing and analysis of big data world across. Till now, organizations were worrying about how to manage the non-stop data overflowing in their systems. Hadoop has changed the economics of storing and evaluating data entirely. Now let's see how Hadoop works and how data is managed and processed by the Hadoop framework. The Hadoop framework divides the data into smaller chunks and stores each part of the data in a separate node within the cluster. Let us say we have 1 GB of fuel economy data. The HDFS would divide the data into 4 parts of 250 MB each. This reduces the time taken to process the data as the work is distributed among 4 nodes. In order to provide high availability, Hadoop replicates each part of the data onto other machines that are present within the cluster. The number of copies that it will replicate depends on the replication factor. By default, replication factor of Hadoop is set to 3. That means 3 copies of the data are found on the cluster at different locations. In order to reduce the bandwidth, it stores 2 copies of same data onto nodes which are present on same rack, and the 3rd copy is stored on different rack. The Hadoop distributed file system takes care of the networking required by the nodes in order to communicate. The major advantage of this framework is it reduces the processing time as the data can be processed simultaneously. This is the brief description of how Hadoop works. In addition to understanding the core components of Hadoop, it's important to understand what are called Hadoop distributions. Let's take a look at those. The first set of distributions are 100% open source, and you find those under the Apache Foundation. The core distribution is called Apache Hadoop, and there are many different versions. The Hadoop version release cycle is quite aggressive. And as consideration when you're implementing Hadoop, most enterprises stay 1 to 2 full versions behind the currently released version because they consider the open source software to be immature and not ready for use in a professional setting. The most popular of these are from the companies Cloudera, Hortonworks and Maper. In addition to that, it's quite common for businesses to use Hadoop clusters on the cloud. The cloud distributions that I use most often are from Amazon Web Services or from Microsoft with the Windows Azure Insight. Here's where it gets a little bit confusing, so let me clarify. When you're using a cloud distribution, you can use an Amazon distribution which implements the open source version of Hadoop, so Apache Hadoop on Oz with a particular version, or you can use a commercial version that's implemented on the Oz cloud such as Maper on Oz. Not all commercial versions are available on all clouds. That's a consideration when you're selecting a cloud-based Hadoop distribution. Thank you so much. Hope you enjoyed the tutorial on Apache Hadoop. Let us learn about Hadoop MapReduce in the next tutorial.